Okay, in chapter 9, we're going to be interested in what determines a function. So a relation is just any set of ordered pairs, right? So basically you've got two sets, usually x's and y's, but any set of ordered pairs. A function is a relation in which for each value of the first component, there's exactly one value of the second component. Okay, so a function is a set of pairs x and y where for every x there's exactly one y. So first of all, here's a relation because it's a set of ordered pairs. And it says write the relation as a set of ordered pairs. So if we're writing a set, I think your MyLabs already have the braces for you. But remember how we write ordered pairs, the x first and then the y. Okay, the x first and then the y. Okay, the x first and then the y. And then the x first and then the y. So that's all that is. Okay, let's ask ourselves though, is this relation a function? If I'm looking at a set of pairs to determine if it's a function, I just look at the x's, -4, 0, 3, 5. As long as they're all different, it's a function. Okay, as long as all your x's are different, it's a function. It doesn't matter if I have the same y going to two x's. I can only have an individual x going to an individual y. Okay, so now it's going to ask me to determine whether these relations are functions. So on this first one, I look at my x's. 0, -1, -1. If those -1s go to two different y's, which they do, this one is paired with a 2 and that one's paired with a 3, that's not a function. Okay, let's look at this one. 5, 6, 7. Then it is a function. It doesn't matter if they all go to the same y, right? As long as each x gets its own y. Each y doesn't have to have its own x. Each x is paired to one y. So let's look right here. Are these relations functions? Okay, so 2 is going to 1, 5 to 1, 11 to 7, 17. Each one of these values in the first set only has one line coming off of it. So yes, that is a function. But look at this one. That 2 is paired with 15, and then it's paired again with 19. That makes it not a function. Okay, if we have something that is a function, then the domain is what we call the x variables, the values of the x variable. The range is what we call the y values. Okay, domain x, range y. Also, you probably won't need these terms, but the x is the independent variable, and the y is called the dependent variable. So now it's not only going to ask us if it's a function, but it's going to ask us to give the domain and range also. So first of all, is it a function? Here's my first set, 0, 1, 2, 3, 4, as long as they're all different. Is it a function? Yes. Okay, give the domain and range. So the domain is simply the values in the first set, and the range is the values in the second set. That's all it is. Okay, so those are if I have the ordered pairs listed in various ways where we can list them, right? Or if I have a graph, this also represents ordered pairs. We've got x's and y's, right? So I can use something called the vertical line test to determine if a graph is a function. If we can draw a vertical line anywhere through the graph and it crosses it more than one time, it's not a function. Think about what that means. That means for this x value right here, there's a y and there's a y. So not a function. Over here, it doesn't matter where I draw my vertical line. There's nowhere I can draw a vertical line that crosses this graph more than one time. So for every x, there's exactly one y, right? For every x, there's exactly one y. So vertical line test is how we tell when we're looking at a graph if something is a function. So for example, I can tell right away that this is a function. Is it a function? Yes, because there's nowhere I can draw a vertical line that will cross that graph more than one time. Now, if we're asked to give the domain and range of a graph, we'd be talking about interval notation. And domain is the x value. So I'm going to look across my x-axis, and graphs are always red, left to right. So when I look this direction, the first thing I come to is an arrow. What this arrow means is this graph is not only going down forever, but it's also going this direction forever, right? That line is moving to the left forever. So, negative infinity. And then there's graph, 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 graph. And the last thing I see is another arrow, meaning once again, it's not only going down forever, but it's moving to the left forever, which is, to the right, which is positive infinity. Okay, now the range of this graph, okay, I'm looking up from negative to positive always. The first thing I come to is an arrow, meaning the graph is going down forever. But if I continue going up, the graph doesn't go any further than this point right here, where y is a 4. Remember, our infinities can never get a bracket. All right, so let's try that again. It's not a function because it doesn't pass the vertical line test, right? It crosses that graph more than one time. So is it a function? No. The domain, if I were to look across this graph, there's no graph anywhere for any of these x values until x becomes negative 2. And then there's a point where there's a graph value for when x is negative 2. So, negative 2, and then there's graph all the way across until when x is 3. After that, there's no more graph. So the domain, in other words, there are x values. I can find an x value anywhere in between negative 2 and 3. And I'm going to do the same thing for the range. Okay, if I go up here, there's no graph, no graph, no graph until y is negative 4. And then there's corresponding graph. And there's y values all the way up until where y is 0. Okay? One more. Is it a function? Yes, because it passes that vertical line test. What's the domain? Well, if I'm looking across here, an arrow going not only up, but to the left forever. And graph, 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 graph. An arrow means the graph keeps going forever. Range. No, let's see. The first thing I come to is an arrow, which is going down forever. And graph, 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 graph. There's another arrow, means it's going up forever. So this one, the domain and range is both negative infinity to infinity. Okay, so determining if a set of ordered pairs or a graph that represents the ordered pairs is a function or not, and then their domain and range.